Hi Geometry! This is the continuation of our lesson on kites and trapezoids. So we're going to start with a couple warm-up problems just to refresh what we learned in the last class on trapezoids and on kites. This first question says, determine whether the quadrilateral is a trapezoid. If it is it an isosceles trapezoid? So we talked about trapezoids and we said a few things about a trapezoid. We said what makes something a trapezoid is there is exactly one pair of parallel sides. So when we say exactly, we mean one and only one, no more, no less. Because if it has two pairs of parallel sides, then it's called a parallelogram. And it got that name, obviously, I would think, because everything's parallel to pairs of sides. But in a trapezoid, only one pair is parallel. And then we know there were a few other things. So we said that a trapezoid is a quadrilateral with exactly one pair of parallel sides. An isosceles trapezoid, remember, was the one where the legs, we call these legs and we call these the bases. So where the legs are congruent. And if those are congruent, then we knew that this one right here, that the base angles were congruent. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. And if a trapezoid is isosceles, then each pair of base angles is congruent. So the converse of each other. We also talked about their diagonals, and a trapezoid is isosceles if and only if its diagonals are congruent. So we'll use that and see if that helps us with any of these. Determine whether the quadrilateral is a trapezoid. So this one, well, it's showing us that this angle is congruent to this angle. And if we were to continue these sides, this would be a transversal. And so these are alternate interior angles that are congruent. And what do we know about alternate interior angles? If two lines are cut by a transversal and they form congruent alternate interior angles, then the lines are parallel. So we know that this is parallel to this. Therefore, this is a trapezoid. So yes, it's a trapezoid. Because the one pair of parallel lines. The next one, let's see, we know that this angle equals this angle, and we know that the sides are congruent, but I can't prove using that information that anything is parallel, so no. Now this next one, we've got congruent. This angle is congruent to this one, and this one is congruent to that one. So whether you made, so this is a base, and this is a base. So whether you had this one on the bottom or flipped it and had that on the bottom, the base angles are congruent. And remember the second one right here, if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So on this, we can say that it is an isosceles. Trapezoid. Because the base angles are congruent to each other. Good. Okay, this next thing says that WEST is a kite. Find the measure of the missing angles. So when we talked about kites, we said that the diagonals are perpendicular, and we said that it has exactly one pair of opposite congruent angles. And remember, they were angle B and angle D. Those were the congruent ones. The ones formed by the that is the only pair that can be congruent. So like the ones that are shorter are like across from each other, the shortest distance from each other. Those are the congruent ones. Yes, those are the congruent ones. Okay, so like in this one, ET is those are the congruent ones, right? Because those are the ones that are closer together. And so that's the pair of congruent angles. So let's see, we have two of the angles, and we know the two that we don't know are equal to each other, but how many degrees are inside of a four-sided figure? 360 degrees. Remember, you do 4 minus 2 equals 2 times 180. So you always do the number of sides it has minus 2 and then times 180. So let's do 360 minus 95 minus 29 gives us 236 divided by 2 is 118. So these are both 118 degrees. The next one, this is 113, so that means this is 113, and you have 113 times 2 plus 37, and 360 minus 263 is 97, so this one's 97. So as we can see, those are definitely not congruent. E is 88, and then we do the same thing, 88 times 2, 176, plus 107 is 283, so 360 minus 283 gives us 77, so this one is 77 degrees. There we go. Okay, so the new thing we're going to talk about today is a mid-segment. We're going to add that to our stuff on trapezoids, a mid-segment. So mid meaning the middle. So the mid-segment is a segment that goes across here. And what it does is it cuts this side in half and it cuts this side in half. Now they're the same, these legs are the same if it's isosceles, but even if it's not isosceles, this still works. So this is for any trapezoid. It doesn't have to be for an isosceles trapezoid. So trapezoid means it has one pair of parallel sides, so that's our parallel side, and then a mid-segment cuts it in half. Now the cool thing about the mid-segment is not only does it cut the sides in half, it also is parallel to the other bases. It has to be parallel to the other bases. So the mid-segment is parallel to each base, and its length is, how long is it? And that's a very popular question to find. It's the average of the lengths of the two bases. So to find the length of the mid-segment, you would do the base 1 plus base 2 and divide those by 2 to find the average. So here's an example. We have a trapezoid. They should mark it with parallel lines, but they didn't. So we're going to mark it. And if the mid-segment we know is parallel, like that, which is helpful with angles. Think about it. If you got another parallel line, then you know that you can find angles because alternate interior angles are congruent, or you know that the sum of the interior angles on the same side have to be equal 180. So things like that can be helpful. So anyway, let's see. We know A is cut in half, and B is cut equally. Oh, I marked it wrong. I'm sorry, guys. Whoops. Whoopsie. Whoops. So it makes this, okay, those equal and these equal to each other. Okay, so let's go back. So let's see, 22, 27, and we need to know what this one is. So we know that, how do you get 20? So we know the mid segment is equal to base 1 plus base 2 divided by 2, right? So fill in the things you know. We know the mid segment is 27. We know that base 1 is 22. We don't know base 2. And we know that you divide it by 2 to find the average. So I need to solve for B. I need to get that by itself. So the first thing I'm going to do is multiply by 2 to get rid of the fact that it's being divided. B is being divided by 2, and I want to undo it. I want to know what B is, not B divided by 2 is. And you can't subtract 22 because it's not 22. Technically, it's actually 22 over 2. So it's just easier to multiply and get rid of it. So that leaves us with 54 equals 22 plus B. And then subtract 22 gives us 32. So this is 32. And it makes sense that it's bigger. If we had gotten 25, then we would know, oh, we did something wrong. So there you go, 32. And that's a great example showing you how to do it when, it's not just the basic, find the mid segment and you're given the 2 bases. Now we're trying to beef it up and make it more challenging. So you have the mid segment and then one of the bases. Okay, so this one says solve for x. Well, to get 37, to get the mid segment, you have to do 17x minus 11 plus 17 all divided by 2. So to get 37, you do 17x, and we can combine those two. So that would be plus 6 over 2. Now, I want to get x by itself, so I'm going to multiply by 2. So that undoes it. So this would be 474 equals 17x plus 6. I'm going to subtract 6. So then that would be 68 equals 17x. And 68 divided by 17, is 4. So, 4. I am tired. Okay, so that is what x is on that. That's all I had to find. So, x equals 4. Nice. Okay, so here is a kite. Sorry guys, the whole time I've been thinking about this and that's just like this is not right. Okay, I did it right the first time. Thank goodness. Because I'm thinking this whole time, I'm so distracted. I'm thinking, how can it cuts it in half. These are marked incorrectly. This should be 1 and 1, and then 2 and 2. Yeah, sorry, these are not correct. I didn't make them. But yeah, because it cuts each segment in half. It goes from the midpoint of one segment to the midpoint of the other segment. So they have to be cutting those segments in half. So that was just a mistake on those graphs. Okay. All right. So going back to kites. I feel better. Let's see. We know that these are perpendicular, and we know that this equals this. And what are we trying to find? Oh, we know, okay, so we're solving for x and y. So we're gonna, oh, this is just nice algebra. 15 equals 4x plus 3. Minus 3 minus 3, 12 equals 4x. So x equals 3. And if x equals 3, then 12x plus 5y is now 12 times 3 plus 5y. So 36 plus 5y is equal to the other side, 27. Oh, wait, whoa. That's not the side. I'm not looking at the arrow. Okay, so let's erase that. My bad. It's the length of this. So this is 36 plus 5y. And this is 24 right there. Okay, so that's a right triangle. So we've got, because it's 90 degrees. So this is 24, and this is, the hypotenuse is 27. So I could use Pythagorean theorem. So 24 squared plus, we'll call this x squared equals 27 squared. So then 27 squared, I'm going to subtract this. 27 squared minus 24 squared is 153. So x equals the square root of 153, which is not a perfect square. So I'm just going to leave it like that. So that's what this is equal to, the square root of 153. And then, so that means that 36 plus 5y equals the square root of 153. Well, not the most beautiful question. So then that means that 5y equals the square root of 153 minus 36. I wonder if there's something wrong with this problem. So this is 12.369 minus 36, so it's going to be negative. And then divided by 5. So y is equal to negative 4.726. What a weird answer. I wonder why it was like that, but I'm sticking to it. I believe I did it right. If you think I did it wrong, you come tell me, because maybe I did. But I think I did it right. We know that these are perpendicular. So, and they told us this equaled this. So for sure, subtract 3, get 12, divide by 4, that's 3. So for sure x is 3, right? Okay. And then, because I knew what x was, I could plug it in and do 12 times 3 is 36 plus 5y. Yeah. Oh well, weird. Find the side lengths of the kite in the simplest radical form. Okay, well, thanks for the warning. We're going to have radicals. So this one is 4 and 6. So 4 squared is 6 squared equals c squared. So 16 plus 36 equals c squared. 2, 4, 52 equals c squared. So c equals the square root of 52. And 52 divided by 4 is 13. So c equals the square root of 4 times 13, the square root of 4 times the square root of 13, which is 2 root 13. So that is simplest form for this. So this is 2 root 13 and 2 root 13. And then we've got another one that is 12 and 6. We need to make this d. So then we have 6 squared plus 12 squared equals d squared. So 6 squared plus 12 squared, 180. So d equals the square root of 180. Let's see, 9 goes into that. So we'll have the square root of 9 times the square root of 20. And 4 goes into that. So the square root of 9 is 3. Square root of 20 is 4 and 5. So this is 3 times 2. So 6 root 5. So this is 6 root 5, and this is also 6 root 5. All right, there we go. Okay, I'll see you guys back in Zoom.